the t-value, okay, the critical value. So we can see that if as you move across here, we go from 0.683 to 0.854. Those are the values of our critical value for t, our t star. So as you move across that row, at what point does our 2.49 overtake that value? So 2.49 overtakes that value once you get past 2.457. Okay, so we wouldn't reject the null hypothesis until we get past 2.457 to the 2.75. Okay, so again, our value 2.49, notice how it's between these two. So what value for alpha, so which decimal down here, or which alpha value, or p-value, would you first reject HO, or I'm sorry, fail to reject HO, is that once you get to 2.750, that's the first time you're greater than the 2.49. Okay, so up here in our curve, 2.750 would be up here. That would be the first time that you went past the 2.49. Okay, so then you would fail to reject HO, because 2.750 would be out this way with 0.01, I believe it is, area to its right. No, I'm sorry, it's I'm looking at the wrong thing. Right here, 2.750, that would have 0.005 to its right. Okay, so the alpha value would be 0.005. Okay. Okay, looking at question number 8. Okay, so a different example now. Okay, what would you guess or estimate the mean GPA of all CCC students is? Okay, well, I'm just going to use 2.0 as an average, okay, for all students. Okay, that would be a C, okay, which may seem reasonable. Okay, maybe it's a little higher, maybe a little lower, but that's what my guess is going to be. So that's what I'm going to guess that the mean GPA is 2.0. Now what I'm going to do is we're going to test that claim. Okay, we're going to test the claim the GPA of all students is different from your guess. Now again, just for my example, I'm using 2.0. So we take a simple random sample of CCC students, and the results are given here. Now I'm going to say just choose an alpha value 0.05 because that's a pretty standard value. If you want to use 0.1, you could. If you want to use 0.01, you could. But 0.05 is a pretty standard value to use. It's not an overly critical number to worry about. Like if you're testing a drug or something, you might want to have a 0.01 alpha value compared to 0.05. But that's just kind of up to you before you start this. Okay, so now we're given a list of data. Calculate the sample mean and sample standard deviation. Again, that's in your 1var stats. So put your values in list 1. Calculate the 1var stats in your calculator. That gives you x bar is 2.514 and a sample standard deviation of 0.764. Now here I'm using more decimal places because GPAs only go from 0 to 4. So that's a pretty compact set of numbers. So I'm going to use, in this case, 3 decimal places. Okay, so we're trying to test the claim. So that's a hypothesis test that the GPA of all students is different from our guess. So our hypotheses would be that mu equals 2.0 for the null, and not equal to 2. Okay, mu does not equal 2 would be the alternative hypotheses. Okay, just like before, calculate your test statistic. Now we're using t because we have a sample of students. Okay, so we have the sample standard deviation and the sample mean. So substitute those values in, and we get 2.691 for the t-value. Okay, so that is our test statistic, 2.691. So are we going to reject HO or not? So what is our decision? Well, on our graph, okay, we draw our t-distribution, and for a two-sided p with alpha equals 0.05, okay, two-sided because of the not equals to, that gives us 2.131 for the t star value, negative and positive because we can be on either side. Our test statistic of 2.691 is farther to the right than 2.131. So that means that that t value is more extreme than we would have expected if the mean really was 2.0. Okay, so our sample mean of 2.514 was more extreme or more unusual than we would have expected if the population mean really were 2.0. So that means we reject HO because we're too far, in this case, to the right. Okay, we're too far out of the region that would have been okay. Anything in here, we would have failed to reject HO. But out here, we're going to reject HO, which tells us if we reject HO, then we're going to reject the null hypotheses and be able to support the claim. Okay, so there's enough evidence to support the claim that the mean does not equal 2. Okay, so it appears that the mean for all students will be different from 2. Okay, now based on our sample, it looks like it's going to be larger than 2, okay, because our sample mean is 2.514. Okay, but we're not going to say that. We're just going to support the claim that mu does not equal to 2. Okay, so that takes care of hypothesis tests given if you're using the t distribution. Process is the same as always, except now we're using t instead of z.